So 6.2, after we finish 6.1, I do need your exams if you have them. If not, email them to me end of today or something like that. We'll go from there. Let's see, whatever we get through 6.2, we gotta get through 6.5. So whatever we get through 6.2 today, probably only half or so. I'll do the rest of the recording for 6.2 tonight, and then also give you 6.3 recording. We're good? I know it's a little bit tough. I'm gonna give it to you up front as opposed to doing it next week where it's gonna even crunch time. We're good? And hopefully we'll go slower, 6.4, 6.5. Be more of a slower sort of pace here.
The homework thing on Friday.
Yeah,
Oh, this is spirit, but it's fine, right?
Yeah, still we have homework, right? I'm gonna put homework in here, and I'm gonna put homework here. That's fine. Yeah, both those would be fine to go over. And if you need, I'll send out the what is those things called? The solution set to them as well. So you have that in front of you in case you get stuck. And we'll do the Friday thing as well. So hopefully in between that.
A final study guide at some point sooner as opposed to later. That would be great.
How about this here? Final study guide.
Just so we can, because I'm so confused.
Yep.
Like switching. So if you just switch sections for the steward, that would be nice.
Yeah. That's what we talked about last time. So good to go. Thanks, guys, so much. Absolutely. Oral final. Then I'm going to give you a rubric for that. Let's see. Let's see. Presentation rubric. There it goes. Rubric.
But that's just the same as always, right?
Slight change. I usually slight change it a little bit here just to get some. I've edited each time I've given it to you. So throughout that. Okay, are we jamming? Let's go with it here. So 6.1 still finishing up. Just a quick question here on this one is I have a velocity between two cars. Just for understanding. Don't even need to write this one down. Just kind of think with me and we'll jump to the other ones because this one just involves just kind of thinking through. But if anything, it's this little piece right here, right? Position or S. The derivative of position is velocity. The derivative of velocity is acceleration. So then if you go up, it goes the backwards way. So I have velocity here. And you talk to me here, what would the area between the curves represent? That's just a quick little question just to get you guys started on a Wednesday morning after senior trip that everybody's tired. I don't know.
The difference in their velocity.
Ooh, yeah, so.
Oh wait, but you go back one.
So when you're like position and velocity somehow.
So it's not the difference between the graphs, right? It's the difference between the area underneath the graphs. So let's talk about it here. So we go this way. So in that case, that would actually be position, right? It's how much they have traveled. Really, it's or you can say the distance, because they are cars presumably starting at a starting line, right? And going forward, right? So you have, so this would be position for vehicle B, right? Right here. So let's say at 4, let's go. So that right here, that would be position of vehicle B at 4 seconds, correcto? Going the other one, this would be position of vehicle A at 4 seconds. All right. 2 positions subtract each other, would that just give us the distance between the cars? I think. Agreed?
Yeah.
It's like a slow agree, right? Like, I think so. Okay. Making sure. Okay, that's all. So just it's this little operation of, if you go from acceleration, this was an acceleration curve, we would see the difference of the speeds between them, right, at that same time. We go from velocity, now we're seeing the distance between them at the same time. Again, didn't need to write this down. This was more of like, hey, check this out. Okay, we're good? Let's go the next two to finish up. So I need you guys to find the area of the region bounded by y is equal to sine of x, y is equal to cosine of x, going from 0 to pi over 2.
Okay, so.
And let's see if we
need
can
to
draw.
find the
Yeah.
one above and the one below.
Yes, I guess we should draw
It's
these
not
out.
very hard, 'cause-
And then we're gonna see if we can do it a little bit different. Let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5 of us, huh? Okay, well, let's do the graph of it first here. So kind of think about the graph of this guy. The sine curve, it goes like this, right, to pi.
We're only going to plan.
So that means we're just going to here, right here, pi over 2. Cosine curve, what does cosine curve do?
One and just.
Starts off at 1 and goes down. Goes like that. And so really, oh wow, look at this. So cosine is on top, sine is on the bottom, and then we get to this point where now it's sine is on top, cosine on the bottom. That is no fun. Where's the point that they cross each other? You should know that from trigonometry. Bless you. Bless you.
Oh wait, I know you need to cover the
Pi over 4, okay, pi over 4, okay. Cool, agreed, awesome, okay. So then we have this on our hands. Oh man, so hold on, are we doing this? So we're going from 0 to pi over 2. Oh, hold on, no, we're going from 0 to pi over 4, right? And we have this situation happening. The top curve is cosine x minus sine of x dx.
Yeah.
Plus, then we go from pi over 4 to pi over 2, and we're going to switch them around. We're going to say sine is on top this time minus cosine on top. That is not fun. Anybody can give me a faster way, an easier way of doing this, please? That is a lot of work. I would say look at the graphs. Go ahead, Sadie. No, look at that was not what you're going for. Okay. Look at the graphs. See if the graphs can tell you a little story.
Are they symmetrical?
Are they symmetrical? That's a good question to ask, guys. Kate's asking, are they symmetrical, yes or no? And I would venture to say yes. Yeah, sine curve and a cosine curve, they do exactly the same spot. They're ebbs and flows of each other, right? They're just shifted over, right? That's cool. So because Kate said they're symmetrical, because we agreed, what's a faster way to do this? So this guy would be equal to this. Go ahead, 2 times.
And why is it 2 times?
Because we have 2 different areas. Area 1 right here,
Oh, yeah.
and area 2.
Or we could just choose either one and then do it twice.
Awesome. Okay, so you either choose this one, and actually we'll do that in just a second here. Could I choose the other one as well? I could have chose go from pi over 4 to pi over 2 of this one. Okay, so let's do this. We're going to divide our class here. Sadie, Christopher, Kate, how about you guys do this one right here? Taya, Enrique, doing that one. Just want to see if we arrive at the same conclusion or not. And maybe I'll do the tough one. This- Say again, Enrique?
Do we not have to do U for this because?
You do not have to do U because you're not splitting it, or there's no function inside a function.
So
You can split them.
negative. Remember one of the homework problems where it was before we had learned U, but I didn't think it had to do it without using U. Is there sometimes where you can just, it's easier to use U even if you could simplify it somehow with an identity or something?
Sure. You could, let's see, you can split off the denominator sometimes, that works,
Maybe sine x.
but generally can't do it.
Or plus cosine x.
Huh? Yeah. Wait, what did you say, sine x?
Plus cosine
Yeah.
x.
Because it's negative sine already, so.
I'll do it the long way, see if we come up with the same one. We good? So I'm gonna do the first one. Sine, cosine goes to sine. So, sine goes to negative cosine. Evaluated from 0 to pi/4. So I'm doing separate from you guys, right? So don't look at mine, Lord. That's no fun. Okay. Sine negative cosine x.
We should find the exact answer to that. Wait, pi and 4. Isn't that, what is that in degree? That's times 6. So it must be 45. That means square root of 2 on 2. Let's see if that's what it is. No, that's not right. It's not right. Because square root of 2 on 2 is about 0.7 and sine pi 4 is about 0.01. But wait, what, okay. Why not
2 or 2?
6? What?
Wow, that's no fun. Okay.
Wait, mine.
Yeah.
Sounds right.
No problem, no problem. Absolutely.
Thank you. I can sanitize it out.
Okay, yeah, that's right.
Sure. Let's see, -1.
So it's square root of 2 on 2 plus square root of 2 on 2 minus 1, right?
I don't know. I'm doing my own. I'm doing the top one, which will be different from yours.
Wait, Kate, is that what you have? Because you had the same thing as me earlier.
I got 0.7.
Oh, yeah, he has that.
Yeah,
Yeah, okay, it wasn't looking.
that's good.
And now I don't know what you were
What did
getting
you
over.
I got -2 minus 2.
-2 minus 2 root 2. I think you flipped your signs around somewhere.
Says the antiderivative of sine x is negative for sine x, right?
Sine
The
x.
antiderivative of that is negative cosine x.
Yeah.
And the antiderivative of cosine x is sine x.
So
And then
minus
No,
you
it's
multiply that by 2.
1.
Yeah, what you have on the left or on the right.
This is what I
guess
have
the
on
left
the
from your
bottom
perspective.
so far. This is very
This
left.
so negative cosine x minus
Yeah,
sine
that's
x.
what I got.
That's what I
Okay.
thought.
So
Oh,
just
right over
keep
here?
going.
Yeah,
It's
and then I
simplified.
plugged in pi over 4.
Unless I simplified it while we were on, I got square root of 2 minus 1.
And so then I got
Then I got what you have there, Kate.
cosine pi over 2 minus 2 sine pi over 2 minus negative 2.
Wait, so it would just be
cosine pi
square root 2
4
over 2?
minus sine pi over 4.
Wait,
Wait.
And
Square
so
root
what I
of
get,
2 plus square root of 2.
when I plug those in-
Square root of 2
I
over
got
2.
-2 minus.
Wait, no, it's not. It is.
Yeah, it's 2 square root.
2 over 2 minus
You and
1.
They have to talk and see where you guys are at on that.
Yeah,
And then you three have to
It's
talk.
I just square root plus negative 1.
The other, oh, are we only doing?
it's just just square root 2 minus
No, we
1.
don't have to put together, because we already said that. But we just
I
divide by
think this
2
would
to
be
be.
negative there.
Because I have it done.
Oh.
So like, basically.
Yeah, and then, but you need to remember to keep the 2 in, because you have that 2.
And then this would also.
Because we're only doing half of it, right, so you have to multiply that by
I
2.
mean, you can.
So it would be.
So you just multiply 2 to the rest.
Enrique, I think you did not put in the
Square root
negative
2
sign inside
minus
it.
2.
Because you have a
No,
negative here.
Or square root 2.
You're
Yeah.
subtracting the 2 between the two.
Or square root
Oh,
2.
yeah. So
Oh, yeah, well, we
negative
divide by
2
2.
plus root
Oh.
2. Yeah.
What'd you guys get? Final answer.
2 square root of 2 minus 2.
Okay, I think I'll agree with that.
Yeah, I got that.
That's what I got.
Oh,
Sorry, Andrea, you're wrong. We got it.
Yeah, I actually got that, so you can promise it.
but I got that too.
Maybe you should put your cloth on, just do it extra time.
Just to make myself seem smarter.
Is that from the 90s?
I need to contain it.
1890s.
Oh.
It is.
Should
That
have
was
done
cool.
What?
15.
No. I don't
People probably wore
want
the
to
same.
buy more clothes. I just had an assignment where I got rid of like all my clothes.
No. For life.
Yeah, I get rid of clothes I never wear. Mine will fall into that category for me.
All your 1590s garb.
You always
I
keep clothes
don't have.
because you might need them at some point.
I am.
No, that's what these clothes are for.
When you need something at some point,
When
what's on the
I need
list?
to wear formal clothes.
So yeah, how are you doing on it? And you guys, they have to decide. We're waiting for them.
Can you show us the next problem if we can start working on it, or is it not?
Sure,
ready?
sure.
There's one, is it just
You have to
one?
remember the 2 is also been distributed to you. So this is everything so far on
And then that
that.
would be one of the,
You
spirit.
Why do we get out of school
So it would just be spirit.
Because
I
we
don't
started
know.
a month late because they wanted to start in person, and it was just dumb.
And we didn't start.
They were just delusional.
The mistake I made.
We started in person a month later, so.
To that first one.
Yeah, we started a month late, but we technically only have 2 extra weeks, right?
Because we had,
Because they just took
they
it
cut
out of all
off,
of our breaks.
yeah, we had a shorter
Okay.
Thanksgiving break and a shorter Christmas break.
Yeah, negative.
Gotcha.
We
Okay.
already
And they
paid for
took out a
those.
bunch
Is Christmas break usually 3 weeks then?
Yeah,
Oh,
Yeah.
okay.
That's what I got.
That's what it was last year.
Okay, cool.
Are we good there? Awesome. Okay, so we just want to show you guys with this one is yes, there's 3 different ways to do this problem, and all of them are correct. Thinking about the value, thinking about the graph, and thinking about which way do I want to take it. Now, I did it the long way. I suggest don't do it the way I did it. That's just way too long, right? If you can shorten it up somehow, please do shorten it up if you can. Okay, example 5, last one for 6.1. Find the area enclosed by this line y is equal to x minus 1. And then got a parabola, but the parabola is actually y squared. How was
not.
that?
Well, you can take the square root.
You could take a square root, okay,
What's the area enclosed by it?
but I don't know, we'll see.
Because it's not gonna go under, it's not gonna become a non-function by doing the squared.
It's gonna become 2 different functions. It's gonna be a positive square root of 2x plus 6, and then we'll have a minus the square root of 2x plus 6. No fun there.
What if we just,
But that's not a function.
It's a parabola. I didn't say it was a function, I said it was a parabola.
That's mean. So we have to do like a weird circle shape thing?
Yep.
Something close?
So let's see how this works. Let's see, it's the square root function, right? Now we gotta think about, okay, square root function is gonna hit at 0 because it doesn't go up or down, right? So it looks like it's hitting at -3. Everybody agree?
Yeah.
Everybody agree there? 1, 2, 3. Looks like that's gonna be our function. So the top one is gonna look like this. The bottom one's gonna look like this. It's for the parabola.
How do we just think, because you can plug that value in and get 0 and also 2 times 3
Oh, yeah,
is 6
okay.
times 0.
Okay, everybody okay with the parabola though? Kate,
But
are you
is
okay with the
it
parabola?
Top function if it's also on the bottom?
Say again?
Is it the top function if it's also on the bottom?
No, So I
No.
guess we can label this. So
Wait,
obviously,
wouldn't the area be 0 if it's symmetrical?
But we have to do the area under, we have to do the other function and get the area in between.
yeah.
Yeah, and real quick, just make sure we note this here. So the area from here to here would be positive, right? The area from here to here would be negative. But if I subtract the two functions, it's going to give me the full area. We're good? Because as long as I subtract them.
Oh.
Okay, and then we have line y is equal. Oh, we got this one. -1 down here somewhere. And I have this little line that's coming across like this. Okay, whatever that is. Oh, there's my area right here. I can highlight it here. Let's see. Highlighter, yellow, love it. There's my highlighter. Boom. Okay, back to my pen.
Wow, that's fancy.
Thank you. Okay, so let's see. The first things first, we have to figure out where our intersection points are, right? So I guess maybe this one, let's do this one on top here first. I have intersection between this and this. So I think I have. Hopefully that works. True. I think so, yeah. Okay.
Why do you set those two things equal to each other?
Because I need to figure out when they intersect each other. Let me
Okay.
find those two out there.
That would make sense.
Wait, why do I have two values?
Huh, that's weird. Let's see. We were gonna square both sides though, right?
Yeah, I square both sides and you move it around until you get x squared minus 4x. Oh, minus 5. Oops. Right, that's fine, but it's still,
Let's see, subtracted 4, subtracted 2x from both
oh yeah,
sides,
-5.
subtracted 2x from both
Minus
sides.
4x minus 5, so then you have x plus 1, x minus 5
X,
equals 0, so that's -1 and
x minus 5, maybe x plus 1?
yeah.
Okay, and then we have x equal to 5 and x is equal to -1. Oh, interesting.
But that's not true.
That is not true. But hold on, real quick here. If I were to set, look what happens here. If I were to set this guy equal to each other, right? That bottom equation. Sorry guys, real quick, back up just real quick. If I were to solve for this one right here, right? If I were to solve for this one, I would set x minus 1 equal to a negative square root of 2x plus 6, right?
Yeah.
And if I were to square both sides, would that negative disappear on me?
Yeah.
Yes. Will we get the same thing again?
Yeah.
Yeah, we get the same thing again. So really, this little x equals 5 is this guy,
But that's not, oh,
and this little x equals -1 is this guy. Now you could do them on both sides. You could say this, well, I'm solving for this guy. I'm going to discard x equals -1, right? Because that's not what I'm solving for. It's just the 5 here. And I find out that this guy is 5, 4.
but
Right?
if you haven't drawn it, couldn't you potentially think, oh, maybe they do intersect in -1? And then that would be incorrect, because when you're using just the positive value, then it doesn't intersect in -1.
Mhm.
So why is it giving you that wrong answer? How can you fix that without drawing the graph and without knowing what it looks like?
Yeah, you can, let's see, 2, -1. Yeah, the only way to fix it, if think back to algebra 2 skills. If you were to plug it back into your, say, original problem, remember these are called extraneous solutions, right?
Oh,
-1 plugs into there, -1 plugs in there, and it becomes a false answer.
okay.
Whereas over here, if you were to graph both sides, square both sides, right? You get the same exact answers over here. But when you plug back into your original equation with the negative inside it, now the now the 5 becomes a incorrect answer. Are we good there? Guys, I'm kind of going a little too fast, but are you guys keeping up? Yeah.
Yeah, I get that.
Kate, we good?
Yeah.
And Enrique, we good with this one?
Yeah, I get that.
The other way to do it is this right here. Notice this is y squared originally, right? The original function. I could have just done this. I could have said, oh, hold on, that's y squared. This guy is just y. So I could just take x minus 1, take it to the second power, equal to this right here. We good? So think back to your original problems, and if you think back to your original problems, you're going to get the 2 intersection points right away. Sadie, does that make sense to you?
Yeah.
Okay, hopefully you're paying attention there. Okay. So this one's going to be negative, let's see, -1 minus 1 is -2. So I got -2, negative, no, I got -1, -2. Everybody agreed there?
So why did we cross out -1? It's because it's not 5 comma 1, and here's where we crossed out the -1.
On the first time around?
Yes. Like why did
Because
cross out?
we were trying to get the intersection point between the square root of 2x plus 6
Right.
and x minus 1.
We
And-
really should have done it with squaring the other one. It would have been so much easier.
Let's see, it would have been better, because here's the issue sometimes. Sometimes it's good to go with the original problem, because then you get the 2 answers and you're done, right? As you look at the graph, especially when you want to isolate something, you want to figure out which one you're actually looking for, and you isolate just that piece there. We're good?
I guess
But-
I'm confused why the x equals -1 is crossed out, but then we are using that to determine the point of intersection.
Sure. Yeah, let's unconfuse you. Ready? So this divides into 2 different pieces, right? A positive value and a negative value.
Right.
So when we were trying to solve this one, this equation is the positive square root of x plus 6. So if I take the positive square root of x plus 6, set it equal to x minus 1, and I start solving because I square both sides. When I go back to my final answer, 5 plugged back in works just fine, because 5 minus 1 is 4, and now I'll give you a 4. When I plug in -1 into here, it gets me a -1, -2, and -2 is not the correct answer to the positive square root of 2x plus 6. Okay, are we good there? So is it better to go back to the original problems and look at them that way? I think so, for the most part. It's better because you're going to get both answers right away. Okay. Our second problem, all yours now. Again, this is about doing it faster, right? Doing it faster. I need to get the area underneath both of those curves. Have fun.
Is the x minus 1 the lower one, even though it's not always, well,
Let's start slicing, right? So if we slice from here to here, the top function is the square root of 2x plus 6. The bottom function is,
Then -square.
but we don't actually have to start there because we can start off with intersection points since those are going to cancel each other out.
oh no, hold on, it's a bounded area. The enclosed area is all this.
Negative and positive, right? Or, oh, because we're not doing that. But, okay, so we can do the 2 times though, right? Because we know that those
Okay.
are symmetrical.
Okay, so here's where everything goes all wacky on us. Are you guys ready? Sadie's saying, why do this when you could actually just start like this? Cancel all this out. Do a double of this right here, right? Up until this point. Does that make sense? And then do the top and bottom from here on out. Can I do reverse on this? I can do reverse on it, huh? Okay, that's one way to do it. And that's a legitimate way, and you're gonna get the correct answer.
But it's slower than-
The longest way to do it is to get this, subtract this, right? That's the longest way to do it.
Yeah.
I wonder, I wonder if we shift this over and actually do y values like this. So notice the top, what we say is the top, but technically it's the right-hand side. The right-hand side is always this line here, agreed?
Oh,
The left is always this parabola here, agreed?
Yeah.
I think I like, so what we're gonna do is we're gonna just kind of like switch it around. Now, we could have done it that way, it's fine. So there's 3 different ways to do it, right? We can chop it off right here, right? And do it that way, or we can go now, let me just check something out. That's no fun. It let go of my, that. So let me erase all this good stuff here and then put in my, so this problem essentially is for us to think about the fact that we can go along the y-axis instead of the x-axis, because it gets too complicated as we go along the x-axis. So yes, we can go y-axis only, let's jam. So let's set this up in terms of y-axis. So instead of going top and bottom, what we're doing is we're going left or right, subtract left this time. We're good? Let's jam. So we have to solve everything for x first of all. So let's jump to, so now actually let's do it. Y is equal to x minus 1. Solve this guy for x. Perfect. Yeah, let me set it up. Yep. X is equal to y plus 1. Awesome. Next one. This guy's y squared is equal to 2x plus 6. Is that right? Yeah. Subtract 6 from both sides. Divide by 2. And I got myself y squared minus 6 divided by 2. Even easier, how about 1/2 y squared minus 3? Is that better?
yeah.
Okay, let's go back. So I got everything in terms of y, this is going to be my right side. True.
Yeah.
This is my left side. And now I know, let's go back to my intersection points here. So what are we going from? We're going from -2, tell me if you guys agree, up to where?
4.
Up to 4. Okay, real quick here, tell me if you guys agree there, because this is the tough part here. This is the tough part to make sure everything all fits together. We're gonna go from -2 to 4. Our top or our right value is gonna be y plus 1 is our r value. Our left value is going to be 1/2 y squared minus 3. Are we good? And so also notice by doing this, it gets getting sloppy here, but kind of keep your thinking caps on just for a little bit. We would have had to use u substitution, huh? Because we have a square root inside it, a 2x plus 6 inside here. With this way, we don't have to use the u substitution. So -2 to 4. Our right value is y plus 1 minus a 1/2 y squared minus 3 dy this time. Another thing, can we simplify the stuff inside here first as well? Absolutely. Let's simplify this as much as we can before we have to do anything else. Negative y squared, -1/2.
-1/2 y squared plus y minus or plus 4.
Plus 4. Okay, tell me if you guys agree with that. And then can we do it then at that point? I think talk to me guys. Everything looks good there? Yeah, let's go then take the antiderivative of this guy. So -1/2, oh, I need to add an extra slide in here. Okay. Let's see the antiderivative. I'm gonna go from one slide to another.
Want me to tell you what it is? Or,
Absolutely, go for it here.
I thought you meant, okay. So -165.
Mhm.
Oh, you're
Perfect.
still on the previous slide, okay.
Um,
That's y squared over 2 plus 4x.
for why?
4y, yeah.
Mm-hmm.
And then -2 4 still.
But so we're gonna add the exponent divided by that exponent.
I guess if we had it the other way, it would have been harder to step, wouldn't it? Because, wait,
This step would have been harder. We would have split up into two different pieces. You would have had to use substitution on your hands as well
no,
during the process.
if we changed, no, we didn't, because I was thinking if we had changed the other functions to y squared, but actually it wouldn't matter because we're just converting over at this point. So we would need to use the things that we did to find the point where they intersect, right?
We still should have found the points of the intersection.
No, never mind.
Okay, okay.
Yeah, I'm not asking it right, and it's not a question because I think I put it wrong.
Okay. Let's see, plugging in a negative, let's see, a 4 to here to the third power.
It's 4 to the third, right? 16 times 4 is, yeah, 64.
64, okay, let me
Negative
put this in here, so
4 over
64.
6 plus 16 over 2 plus 16
16 minus
minus
-2 into that, huh?
negative minus 8 over 6 is it?
Mm-hmm.
Oh, yeah, yeah, so it's negative, negative, but then there's a third negative. So minus 8 over 6 plus 4 over 2. Oh, but it's
Let's see, I have a
over
negative,
minus
I have a
seven.
-8 times a -1/6, right? So it's 8 over 6,
Yeah,
right?
but yeah, so eventually you'll still be subtracting it, but
Uh-huh.
you're not subtracting it and subtracting it, which would be adding it.
Correct, uh-huh. And this one be 4 over 2, right? 4 over 2?
Yeah.
And then 4 times -2 is -8. Okay, let's see what we got here. So I can drop the parentheses as I go as well here. 64 divided by what? By 2, I guess?
Negative 32. Yeah.
32 over 3, perfect, thank you. 8 steps in here, 16 in here now.
Plus 16 plus 8. I mean, if you wanted to just combine those.
Oh, that's right, yeah. I'll combine them just a second here, just to make sure that all these
What
are
actually
coming
there's
in.
another 8. 4 over 3. Plus there's not 2.
Oh, that's right, yeah, uh-huh. Okay, what is it, 4 over 3?
Minus
4 over 3.
3
Uh-huh.
plus 1/2 minus 8. Or
Minus
minus
2
yeah, sorry, minus 2
plus 8. Uh-huh, okay, that's cool. Oof, combining all, so this is gonna be -36 over 3. Combine the 3's together, was that 24? 24, 22, 30? I got 30 here, is that right?
Yeah, and then
That's gonna be -12 plus 30, which is 18. Who would call the work for an
how in
18?
the world 30? Stuff like this makes me feel
18
very smart.
Yeah.
And then, Mr. Computer, for all the problems, what would you like us to put for the unit, like on test or homework? Should we just say 8 units or I mean 18? 18 units or just 18?
Just 18 for now, yeah.
Okay.
Yeah, because there's no unit value still when we start actually application questions, and it would get units.
Cool, thank you.
Okay, are we good? Awesome. Let's see, got 20 more minutes. So that was the end of 6-1. Let's jam at the beginning of 6-2.
So we have a lecture for 6-2 and 6-3.
Yeah, and hopefully it'll be like half of 6-2 here. So lecture and a half-ish.
Where did you get the 30 from?
30? Oh, yeah, it
I
was,
got 34. I don't know what I did wrong.
8 plus
That's
8 is 16.
24.
24, yeah.
8 plus 8 is 16.
Oh,
16 plus 16
okay, I
is
added
32.
2, never mind.
Or that way. Mhm.
Yeah, okay.
One of the hardest things is following someone else's mental map.
Uh-huh. Okay. This one was just from the textbook. I just figured I should copy it. So this is just means that we could take it with respect to y whenever we like. And sometimes it works even better.
Wait,
Sure, this one,
it's just telling you.
telling you can do, it's f of y minus g of y. We always go from right to left. The subtraction process goes from right to left. And then we go from there. Okay. Jan, let's keep this one here. Let's jump to 6.2. Awesomeness. Love it already. 6.1, two-dimensional, is that right? We were looking at area, right? Underneath a curve and area between curves. That was 6.1. 6.2, let's talk about volume. Let's talk about three-dimensional stuff now. And so let's think about how volume works. So don't need to write anything down. Just kind of think with me as we go. Volume, a rectangular box. Volume is length times width times height. Good, good.
Mhm.
And if we think about this here, isn't length times width just the area of a rectangle? And then what we do is we kind of multiply it by this little height value. In fact, that's more like the generic way of thinking about it. Notice right here, what's really the base that we see here? It's a circle. It's right there, pi r squared. And then all we do is we just multiply by the height each time. So then if I have this little weird thing, I'm going to just say, whatever this is, my area of that base times the height.
The
Or,
height's curvy too.
oh yeah, then that's the fun part. We'll get to that. Or I could do it like this. Let's do it the calculus way. Could I slice? Doesn't have to be the base. Can I just slice a circle somewhere here? I think I can. I love it. I love slicing. Okay, so then can I do the same thing here? I'm going to slice.
Oh no, you're just.
Times the height.
As long as I have my slice correct, right?
Yeah.
Then I just figure out how much height I have for each one. Love it. Okay, three-dimensionally. What does this look like in calculus? It looks like this. Oh, as long as I can figure out the area of this little piece here, as long as I got the area, I can keep on integrating from A to B, and that would get me the whole entire piece of it. So I got to think about it in terms of area though, right?
It's
Not in
just like
terms of,
doing the area under a curve where you're taking really small slices. Going to infinity and going to infinity if you're doing it. But here you've got three-dimensional. Is that the same idea?
three-dimensional, yeah, and the only thing that we've got to think about is this whole concept of we're trying to get area in here. So from 6.1, how does it connect? Is we're going to try to get, instead of slicing, you know how we just did this last one, which was like this right here, and we talked about slicing like this, right? We're thinking about this whole piece as that slice.
Yeah,
That's
so
my
it's double
slice.
sliced.
Yeah, that's my slice, and then I'm slicing forward or I'm slicing backwards away from it.
It's like the way muscles work. You go have a piece, and then you
Uh-huh.
go smaller, and there's another piece, and then you go like smaller and smaller, and then you spin back out, and the muscles contracting. But every little thing, even like the tiniest things are.
True, yeah, or even, yeah,
Slices of slices of
Mhm.
slices.
or MRI scans, right? Technically, you keep on slicing. It's just a whole bunch of different slices of pictures, really. That's what, and then you figure out if the organs are in the right position or if the organs are inflamed. You do it by, technically the person is So funny, the radiologist, he's scrolling through, and as he's scrolling, he's seeing like the heart, right? Let's say a slice of a heart, right? He's seeing how big the heart is and it comes back down, right? Because he's imagining the three-dimensional piece of it. That's as he does it. Anyways, that's pretty cool. So let's jam. So same thing that we had before. We're just gonna take, how do you get volume? And this is the one that we want right here. Volume is just going from A to B of an area sliced.
Makes sense.
So first things first. So if you guys want to write down just that one right there, right here. So
What if-
volume.
Wait, maybe this is already, this might be a stupid question, but something has like different amounts of, it's not, like if something's has a constant, like the slice is all the same. and all of
Mhm.
it,
This is where A
That's
is a
one thing, but if the
continuous
slice is changing, you have to keep on doing it, like, how do you,
Yeah, you keep on doing it, or you figure out a formula that will allow you to see the change
okay,
each time. So you got to figure out the change.
yeah, so that's
In-
actually what we're doing.
Yeah, in a context of an area, that's the issue there. Okay, so let's go with it. Let's see, 15 minutes left here. All the way through, I think we have 9 examples, so we're gonna try to get through 3 or
There's no
4.
way we can do 9.
Yeah, so we're gonna, let's see if we can jump to 4 at least. Okay, let's jam. Let's actually prove something. This would be kind of cool. So we have this right here. What is the area of a sphere? The volume of a sphere. Volume of
Pi r
sphere.
squared,
So again,
pi r squared, isn't it
It has a
4,
cube
is
in
it
there
4/3 pi r cubed?
what is R?
That's right.
Volume of a cube is
I see.
4
How
over
to do that on
3.
the test?
Yes, that one. That's right. It all fits together. Okay, guys, let's go for it. Let's actually derive the formula of a sphere. How do we do it? I gave you a little piece there. So maybe I find it easier just to actually go from where to where first. So let's kind of put this together in pieces here. So I'm going to slice from where to where. Looks like from negative R to positive R. True, true. Okay. And then that's one thing I noticed. Okay, the next thing I noticed is the fact that I have a circle here. And so think about back to circle. What's my formula for circle is pi r squared, correct? What do I have here? Or what's my radius? Or what's going on here?
Is your radius y?
Yeah, radius is y. That's cool. So I have pi y squared. That's nice to me. Next,
So what is it you drew before pi y squared?
where?
Before the equal sign down the bottom left?
Pi r squared. So this is a circle. There it is, pi r
Oh.
squared. Now I have pi y squared. That's cool. And then notice that I have this little so hold on. So when it's right here, right when it's right there, right, it has to be an R value, right? And the R value kind of just switches down to nothing as you get closer and closer to it. So I need to sort of make this curve here. How do I make this curve? So that I have this right here. That's what I want.
But you're saying, how do we say what the formula for the curve is?
Yeah, I want this curve right here, just from here, right, to here. If I can get that, I need somehow so that at 0, for x equals 0, right, I have y and r exactly the same. And then as it gets closer and closer to r over here, it's gonna just, y becomes nothing. So I need that formula that creates that.
That's what you asked for, isn't it?
Oh, yeah.
Would it be area for a sector?
Or,
Area of a sector, maybe.
Is that what you're asking?
No, because I'm not asking for an area value. I'm just asking for just a component. I'm just trying to figure out the R value here. I'm just trying to figure out this guy. I
it's
got
not
the
the area
pi.
of the sector, but it is the curve of the sector.
So I want Y to be the same thing as R, and I want these guys to be the same here. But when I get to here, Y should be 0. I want it to just die down. And this is probably the toughest part here. The toughest part is if you have, sometimes you're given it and like, oh, that's easy. And sometimes like, I got to come up with a formula that actually makes that happen. That's my trouble.
Is there some way that we can't, well, I just don't even know what to think of.
Yeah, no problem. I'm
So
just
what-
letting it.
Is there some way that we can, is there something that's the right direction that we can think of?
Mhm.
to see if we can-
Yeah, so we're going to be slicing, right? Notice we're slicing in terms of X each time. X will be a value that we get.
Yeah.
So we want to slice in terms of X because we're going to start here, right? We're going to slice horizontally. We're going to eventually finish here. So that Y technically has to be in terms of X. How about that?
So.
Wow, we made so much
Is
progress.
it like, is it something where you have an R, like Y equals R, kind of like an exponential decay function, but it's not exponential.
Yeah, it's not exponential.
But where as you go up with X, you're going down with,
Hey, that's cool. Yeah, as you go up with X, especially after 0, you're going to go down with Y in a curve.
so it has to be where that Y can equal, there has to be something so that Y can equal R when X equals 0.
Yeah, or is it just,
Okay.
if you want to draw it out, just slice this out, just this little piece right here. I need this right here. I need to figure out that. So I need to figure out,
Is that just, oh no, it's not.
a relationship.
It's too round. Okay, I mean, it's a quarter of a circle.
Hey, that's good. We're getting to circles. That's great. We're getting to circles. I like that. And so somehow X has to be inside
Still
here.
not X, yeah, we need to put X in there. How can it? Could it be like, this is stupid, but X, well, that's, or pi r squared divided by 4 times like X plus 1 or something, so that when X is 0, you just, but that's not going for r squared. We have to get it maybe, or put pi on 4 in there so that you can make it so that it equals just r when X is 0. Would it-
That is so interesting. Yeah.
Or 4 pi.
Let me give you guys this here. What do we know for a formula of a circle? Up to here. Like that's X and Y, right?
Oh, is it something to do with sine or on the unit circle, but that's not.
Yeah, if we're on the unit circle, it would have been 1, right? But we're actually on our circle, right? Because that's R right there.
Y
So-
squared plus X squared.
X squared plus Y squared is equal to R squared. I think we're getting somewhere.
Oh, so
Isn't that give us a-
solve for that, yeah.
That's so cool. So I think we're onto something. Kate, I'll take it away. Don't we have a Y value here? Aren't all we're just trying to do is get to the Y value? Can we solve for Y squared?
But that gives us, Oh.
What is y squared?
R squared minus X squared.
I love it. Done.
And then when
Because
X
I
is
just
0,
have-
then we just have R
Uh-huh.
and then.
And when x is r, we get 0, right?
Oh, yeah.
Sweet, I think I got this. So hold on, let's see. First things first, it has to be an area. Area is this right here. And that, so we're gonna go to pi multiplied by r squared minus x squared. Are we good there? I'm gonna drag this all the way up here. So we got pi r squared minus x squared dx.
That equals y. Wait,
Uh-huh.
that equals y squared. Yeah.
That is equal to y squared.
But do we want y squared?
Absolutely, we want y squared because that's our formula, right? Because eventually it goes back to here. Here's our area formula for a circle. We plugged in the value of the slices that we wanted. We got it in terms of the y value, the height that we need.
Yes, that makes sense, but why is the area equaling y squared?
Talk to me some more. Sadie, go ahead. Why is the area equaling what? Y squared?
Why is pi r squared equal? Is that a different y squared?
Oh, that's a different r. Sorry. This is the generic formula for,
Yeah.
that's the generic formula for
Different R.
circle.
Yeah, I get that, but why is that y squared?
Because r has to be squared because it's a radius. 'Cause
Is it a different y?
that y is the
Where-
same.
Where's the other dimension? Where's the squared?
So let's talk about this here. Let's see. So if I was dealing with a square, which we'll deal with a little later on, what we do is we would have a length times a width. That's what we have.
No.
Because we're dealing with a circle, our circle formula is pi r squared. The radius that's happening is the y value. So it's y squared. As we slice here, y is very big. As we slice further down, y gets smaller. As we get
Oh.
smaller, y gets smaller and
Okay, never
smaller.
mind. Yeah. never
Good?
mind.
Yep, that's cool. Okay, first things first, or actually, can we make this even easier? Can I do like half of it only?
Why would you do that? Oh, from 0 to r.
I like it. Are we okay with going from zero to r and doubling it and actually moving the pi out? Why have the pi there when it's just being moved out? Pi is a constant.
R squared minus X squared.
Uh-huh. dx. Sweet. Okay, now let's go for it here. So 2 pi is going to be the outside. We are going to go with, let's see, pi rx, or x in front, minus x cubed over 3, evaluated from 0 to r. And that's what I'm looking for. And sorry, guys, I'm going to move things around like right over here. Plug in oh, I like zeros still, guys. Zeros are great.
So does 2 pi have to get multiplied when we plug in R and when we plug in 0?
It usually stays on the outside until everything is done, and then we just multiply it in afterwards. Why do you distribute where you're going to be subtracting stuff out anyways? Okay,
So R squared.
r plugged in, r times r squared is r cubed. Then it's r cubed over 3. And zeros plugged in will just give you 0, so why mess with them anyways? Three r cubed over 3 minus r cubed over 3 makes 2.
Wait, 4. No, that's an equal. Oh, there is a subtraction. So then we have 2
Very good.
times 2. No,
Bam.
no,
What do you guys say? That's pretty cool. I think that's cool.
Yeah, that is.
And so what we do with calculus, we actually derive, eventually you derive all these geometry formulas from a calculus point
It's
of view.
kind of mean that we always use them and never realize.
How does it mean?
Well, I don't know, it's just like everything is calculus.
There you go. Thank you so much for saying it. Yes, everything is calculus. I was hoping someone would finally say that.
Well, it's mean in that we just didn't, we were so like, oh, we're just using a little formula. Oh,
Yeah, we should teach calculus first before algebra and geometry.
Sure, I'm sure how that will go over, yeah. Okay, so I'm gonna give you guys a video of 6.2, the rest of 6.2. Sorry, guys, I'm gonna put the burden on this week, so then next week will be lighter. Then I'm gonna give you a video of 6.3. Good. Homework. Send you guys the homework assignments for chapter 6, and then send you guys the solution sets for chapter 6.
If you could, well, I don't necessarily want to ask this because it's not actually benefiting me, but it would be sort of nice if the homework assignments were slightly shorter, but then again, then I don't learn it as well, so I don't know.